always, we're going to start with a free body diagram here. And I'm envisioning this car like this. So here's our road. There's the center of the turn. Here's our car over here. Those are the wheels. That's the headlights. So it's not a great picture, but this is a car that's sort of at this edge of the turn and it's driving out toward us. So if we draw a free body diagram of it when it's in that position, of course, the Earth pulls down on it. That's the force of gravity. The ground pushes up on it. That's a normal force. Those two are going to be balanced because there's no acceleration here in the up and down direction. As we know, when something moves in a circle, there has to be an inward force. Now, by the way, don't label this Fc for centripetal force. Centripetal force is not a type of force. It is the word centripetal is a direction that forces point. So it's not a new type of force, just any force that we've talked about in the past can point toward the center. And since it points toward the center, and centripetal means toward the center, you could call it a centripetal pointing force. So anyway, in this case, the force that points toward the center is friction. And that's because, if the road were icy or snowy, then the car would slide off in a straight line. And so it really is friction that holds it into its circular pathway. And actually, since we're trying to find the maximum safe speed for a car to go around a corner, this isn't just friction. This is maximum possible static friction. So it is just about at the point where the tires are going to break loose and slide instead of grip the road. So what about the other direction? What about the outward direction? Is there an outward force? Well, there could be, as long as it's smaller than the inward force, because when something's moving in a circle, the net force always has to point inward. But in this case, there isn't anything that points outward. Remember, forces are exerted by objects, and there is no object that's touching the car that could possibly exert an outward force on it. So that's our complete free body diagram. Now the net force formula for moving in a circle looks like this. Net force in a circle, net centripetal force equals mv squared over r. And of course, on this side of the equation, this literally means add up the forces in the centripetal direction. Actually, I think in some ways it's better called the radial direction, the direction that is parallel to the radius. And that's this direction right here. This direction is parallel to the radius of the circle. So the only force there in our diagram is the Fs max. By the way, I made it positive because when you're doing a circular motion problem, anything that points inward is positive. Inward is always positive. That's more important than up, down, left, or right. If it's inward, it's positive. If it's outward, it's negative. Okay, so one of the things that's a little challenging about this problem is that you're not given the mass. And that's not uncommon for a physics problem. So what we want to do here is get mass on the other side of the equation. We have mass on this side of the equation. If we can get it on that side of the equation, then we'll have it on both sides and hopefully we'll be able to cancel it mathematically. And it might not be immediately obvious how to do that, but the best thing to do is start trying things. What could I replace friction Fs max with? And maybe by replacing it with something, we'll get closer to our goal of canceling out the mass. Well, the obvious thing to replace it with would be the formula for maximum static friction, which is coefficient of static friction times normal force. And that makes me feel like we're in the right direction because we're given the coefficient of static friction. It's 0.8. And so now we could put that number in here. So we've substituted in something that we have a number for. Now we still don't know what normal force is, although now we can take a look at our diagram and see that the normal force is balancing the force of gravity. As always, force of gravity is m times g. And since the normal force is balancing the force of gravity, that means we can replace normal force with m times g. And there it is. The mass is now on both sides of the equation. All terms have an m in it. So technically, we're going to divide both sides of the equation by m. It's going to cancel out from both sides. And we're looking for the maximum speed. So if we rearrange this, we get v is equal to the square root of r times the coefficient of static friction times g. So in this case, that's going to be the square root of r. The given radius is 26. Coefficient of static friction is 0.8. G is 9.8. Let me do this on my calculator real quick. I believe the answer is around 14, but let's give it a try. So 26 times 0.8 times 9.8, and then we got to take the square root of that, and yes, 14.3 is the final answer to this question.